$1. These are bills. So if there is 7 envelopes, 1, 2, 3, 4, 5, 6, 7. Please make 7 envelopes off to the side. And we're gonna put the common bills in there. So the lowest bill you could have in American money is a $1 bill. So there's one of the envelopes only has $1. What's the next size up? 5. Now, I know there's always the exception. Some kids like, there's a $2 bill. It is actually true for a very short time. The government, a $2 bills is kind of a novelty. And yep, my father-in-law used to really love those things, so he bought them and gave them to everybody that he knew, and it's kind of a fun gift. All right, but it's kind of weird because then you can never spend it, in a way. I know you can.
Yeah, at work.
Have you spent them?
Yeah.
Okay. I just don't spend them because I only have one, and I don't want to use the only one I have.
At work, it might tell there's a $2 bill, so I mean.
Interesting. Okay.
Maybe someone who just didn't know. Someone just took it.
Would you please write 1, 5, 10, 20? Am I missing any here? 50, 100, 1, 2, 3, 4, 5, 6. Oh, I had 7 envelopes. Dang it, there's only 6 envelopes. Sorry, erase your last envelope if you had a 7th. Now, let's make it really simple. If you roll a die and you roll a 1, you get $1. You roll a 2, you get $5. You roll a 3, you get the 10. I think you get the idea. You roll a 4, you roll a 5, you roll a 6, you get the 100. Now, I'm not that crazy though. Let's say that I charge to play the game. Would you pay $1 to play this game?
Yeah.
Yeah, because the worst case scenario, you get the buck back, right? Would you pay $50 to play the game? No, because that's too expensive, obviously. So everybody figure out, in your best guess, I know I haven't taught you the math, that's what I'm about to do, but what's your best guess on the fair price? There's a price that's the exact fair amount, and that's what's called expected value. It's the average of, if you played it 100 times and you took all the money you won and you divide it by 100, it'd be the average amount you won. That's what the fair price would be. So don't say it. Please write down your best guess. And there is a right answer. And all I'm asking is, are you a good guesser or not? So, write down your number. And in a moment, I'm going to ask you to share it with somebody, because you know what happens. Once I say the answer, and let's say I say the answer is $42. And, some wise guy's going to be like, I had $42. Yeah, sure. I want you to show it to somebody so you are accountable. And that person will be able to be like, no, you didn't have 42, you had $12 or whatever. So would you please show somebody your best guess on how much is the fair price to play this game? Show the person next to you. Nobody knows. Just take a guess. Jordan, show that guy. Teo, show him back. All right, you guys got to include each other. All right, so now you all showing somebody. Who's willing to share? They're pretty, I feel pretty good about my number. Some people were like, I have no idea. It's fine. Who feels good about theirs? Yes?
I'm not going to say it until you say it.
No, I'm not going to tell the answer yet. I got to tell you how to do it, but I just wanted to know somebody's guess. Yes?
31.
All right. Anybody else have a good guess? Yes?
36.
All right. Who else wants to go on record? I feel like... See, after the first 2 people spoke, now anybody who had $10 is going to be like, wait a minute.
15.
That's way too low because the other people said 30. So I didn't want them to talk until everybody already had their guess.
I feel pretty.
All right. Okay. So now we could pick what's called an under-over. If I said the number was $24, and I'm not saying it is, would you say, I think it's under that? Or, I think it's over that? That's the under-over. 24, is it under or over?
Under.
Would you please put a thumb for up, that's over that. or down, it's under that. 24, under, over, under, is it under or over that? 24 is the number. Come on, let me go on record. Is under or over that? You don't know. Okay.
You get it in this one instead of 24.
All right. Well, here's how you actually do it. And everybody please write this down. P times A, then add. That's what this is. And P stands for probability, and A stands for the amount you get. And then you add them all up. You do P times A, and then you add. So here is the probability of getting this. It's 1 in 6. Here is the probability of getting this. It's 1 in 6. Well, that's going to get boring. It's always 1 in 6 probability. 1 in 6, 1 in 6 chance, and a 1 in 6 chance of getting 100. So I will ask Siri for some help here. What is 0.17 times 5? Because that is 85 cents. And 0.17 is the same thing as 1/6.
Yeah.
It rounds to 0.17. And I can times that by 1 in my head. And I can say that's worth 17 cents. So 85 for this, 17 cents for that. And I can do this one in my head again. Because it's 0.17 times 10, that's worth $1.70. And 0.17 times 20, that's going to be double 170. It's going to be $3.40. And this spot's where they start to get really worthwhile. What is 0.17 times 50? 8.5 for that one. And I bet some of you are feeling better about your guesses now. Oh, that last one, I don't have to multiply that in my head. I can do that. It would be 10. Sorry, 10 point, it was 1 point, it's 0.17, so it'd be 17, thank you. Technically, if I extend the decimal out a little further, it'd be 17 point, we'll just round it to 17. Okay. What is 17 plus 8.5 plus 3.4 plus 1.7 plus 0.85 plus 0.17?
Wait, what is the A stand?
Sorry, my
It's 31.62.
amount. A stands for
Oh my
amount.
God.
What is 17 plus 8.5 plus 3.4 plus 1.7 plus 0.85 plus 0.17? 31.62.
You definitely cheated. No. Adding them all
He
up.
definitely used math.
I did 186.
You add them all up, right?
Yeah, you add them all by divide by 6.
Exactly. The reason that worked is because the probabilities were all the same.
Yeah, that
And
wasn't a guess. That was.
in the real world, I wasn't cheating. You can't use your brain? That's not fair. That's cheating. Okay.
It is.
So anyways,
Yes.
the answer was about 31. Who had an answer that was around 31-ish? Ooh, a couple of you in that neighborhood. Okay, good. So now, here's another one, and it's going to be the true test is do you remember what I just said? Probability times the amount you get, and then you add them all up. All right? This one is going to be different because there's going to be different probabilities. It's a spinner. And the spinner has a 1 in 4 chance of hitting here, a 1 in 4 chance of landing there, and a 50-50 chance of landing there. And here you get $5. Here you get $20. And here you get $100. Would you pay $5 to play? Yeah. Would you pay $100 to play? No. Would you pay $20 to play? That's where it starts to get fuzzy. Some people saying yes, some people saying no. So do the probability for each. There's a 1 in 4 chance on this one. There's a 1 in 4 chance on that one. And there's a 50-50 chance, also known as a 1 in 2 chance of that one. P times A, and then you add them all up. No fair using your brain, though.
You don't need to like. What is the P again?
Cheating.
Probability, but then when we choose it.
What is 0.25 times 5? And it's 1.25. What is oh, I can do the rest of them in my head. 1/2 of 50, that's, or half of 100 is 50, that's easy. And 1/4 of 20 is 5, because 5 times 4 is 20. 5 and $1.25 and 50, holy cow. That's worth $56.25. But at the casino, they would charge you $60 to play because they want to make money. Is that evil? No. If they set their price to less, then they'd lose money on average every time somebody played. They would lose tons of money. That's not why the casino is there. They want to make money. So of course, they're going to charge you more than the average winning, right? But do you get the casino would be stupid to charge $100 because nobody would play? Everybody be like, well, that's stupid. That's not fair at all. So all casino games are usually rigged with like a 3 or 4% win rate. So they win an amount that's small enough that everybody thinks, yeah, that's almost fair. And so, but then they make money because on average, the average person that goes into a casino probably bets over the whole night, bets like $1,000. And if they can get 3% of their $1,000, that's $30 profit for everybody that walks in. And I actually heard the number the other day at one of the casinos. Their average was $50 per person that they win. But if you times by how many people are walking into the casino, and they get like 1,000 people come in and they get $50 profit, that's $50,000 profit from on average for that one night. And so, yeah, they can make good money. I'm not saying every casino everywhere, because some casinos don't get enough people in them to make it work. But if your casino gets lots of people, they can make lots of money. Okay, so one last one. We're going to do the envelopes thing again, but it's going to be just a little more complicated. There's 4 envelopes that have $20. There's 3 envelopes that have $10. And there's 3 envelopes that have $500. So imagine this is a fundraiser thing. And they said, okay, moms and dads, we've invited you here tonight to raise money for this, I don't know, whatever the charity is. And to play the game, it's going to cost you $100. Some people would definitely play. They got a chance to win $500. Would you pay $100? I don't know. Let's say your mom says, you're smart. Could you figure out for me what's the fair value of this game? What's the probability times the amount for each thing? Here's the amounts. They just got to figure out the probability. So help out your mom. Figure out the fair amount. I'll pause for a second. See if you can find the expected value for this game. And you might be like, but I don't know how many envelopes there are. Yeah, you do. There's 10. 10 total envelopes. But I don't know the probability.
Would it be 9 or 7 stuff?
How many envelopes are there? So then you've got a whatever in 10.
Other one you did 6.
There's different amounts, right? That's why that's the challenge. So it's 10 envelopes this time. So what's the probability of winning this? 4 out of 10. What's the probability of winning this? 3 out of 10. And you can use a calculator, and I'll pause for a second. And this one's 3 and 10.
How do you get...
How do you get what?
No.
Finish it. It's okay.
I just don't understand how you're finding the things. Like, what do you... You're doing
The
one
probability?
times- Yeah, you're doing 1 over
It's-
10, but then what are you doing for that? Times you get by 12?
way I would think of it is this. For probability, to get probability, it's the things that you want. I want 4 of the envelopes to happen out of 10, out of all that are possible. And there are 4 of these kind out of 10 possible envelopes. Probability is what you want divided by what's possible. So take the probability times the amount and then add them all up. Pause for a second while you finish that. All right, so we got a grand total expected value on that one. After the price of $100 to play the game, the expected value was $61. And what was that formula again? You take the probability times the amount and then you add. A lot of you had a good sense of how much the game should cost. A lot of you were pretty close when I said how much would be fair. But do you get all it takes is some small percentage of the population to be terrible at guessing how much things are worth, and they go into the casino and they don't have any clue and they just lose tons of money because they're not very good at guessing what things are worth? And maybe some of you are that person. Well, just be aware, the casino gives you plenty of chances to get. There are some games that are really, really not in your favor because they want to have some people lose lots of money at those games. So, be smart. Know the casino's always rigged against you. All right, this is the part where you have to open up your Schoology quiz. There's a 3-question quiz, literally just 3 questions. Would you read the first one and I will help you complete the first one. Everybody find the Schoology quiz? Excellent. Just fire away when ready.
You're going to play a game. You have to pay $1 to play.
Okay.
When you draw a face card, you net $3.
And just so you know, face cards are like the ace, king, queen, and jack. And I will tell you how many face cards there are. How much do you get if you get a face card?
$3.
$3.
If you draw anything else, you lose your $1. What is your expected value?
All right. The others, the way I like to think of it is all the other cards, I get $0. And then later I'll factor in the cost at the very end. First I figure out the price that you would win, and then I subtract off the $1. Okay, so now I know most of you don't play cards enough to know how many face cards there are. There's 4 clubs, 4 hearts, 4 diamonds, and 4 spades. That's 4 times 4 is 16 face cards. And then we'd have to know, what is 52 minus 16? It is 36 other cards. You with me so far? Then what's the probability you'll get a face card? 16 out of 52. And what's the probability you're going to get an other card? 36 out of 52. And I do probability times amounts, and then I add them all up. Well, 0 times that is definitely 0, so that was quick. Add it all up.